Welcome to Control 4 Driver Development Essentials. My name is Peter Cosenza. In this video, we will walk you through the steps required to create a Control 4 driver for an IP camera. In doing so, we'll use two tools delivered by Control 4 to assist with the driver creation. The first is Driver Editor version 3.0. This latest version of Driver Editor is a driver development environment that provides a graphical interface for the creation and modification of C4Z files. It is important to understand that Driver Editor 3.0 and all subsequent Driver Editor releases are compatible with C4Z files only. If you are new to C4Z files, we'll discuss them in the beginning of this video. The second tool we'll use is Control 4's latest IP camera driver template. Control 4 is currently in the process of delivering driver templates for many of its more heavily used proxies. Driver templates are delivered with Driver Editor. When a template is selected and loaded into the Driver Editor environment, it offers a powerful development scenario that can reduce development time as well as improve code quality. In this video, we'll use a template specifically designed to help create IP camera drivers. In viewing this video, and all videos found in the T201 series, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T101 video series. You may find it useful to review the information offered in those training modules before you proceed to develop template-based C4Z files. Before we begin creating a driver for an IP camera, it might be useful to briefly discuss C4Z files. Beginning with Operating System 2.6.0, Control 4 has changed the file structure previously used to support device drivers. Up until 2.6.0, device drivers were contained within a single file using the extension of C4i, or drivername.c4i. The release of 2.6.0 marked a significant change to this model with the introduction of the C4Z file structure, or drivername.c4z. A C4Z file provides all of the contents that the C4i file previously did. However, it offers some significant features and advantages that its predecessor did not. At its most basic level, a C4Z file is a zip file. It contains numerous folders and files which, when encapsulated into a C4Z file, represent a device driver. The modularity within the C4Z file enables a far more organized and structured approach to device driver architecture. It also provides the ability to include many related objects within the confines of the driver in an organized manner. These objects include items such as graphics and icon directories to support custom user interfaces which can be run on Navigator. A C4Z file also contains one or more Lua files, which contain all of the driver's Lua code. Control 4 driver templates take advantage of the C4Z structure by delivering libraries of commonly used Lua functionality. These can now reside in one directory location and can be easily referenced. A C4Z file also has its own XML file, which separates the XML portion of a driver from the Lua code. Additionally, rich text documentation can be included in the C4Z to support a far superior user assistance model. This camera driver development video is designed to be viewed in two parts. The first section provides instructions on how to use Control 4's camera compatibility driver. This driver can be loaded into a project and modified through the Properties page to quickly connect to a camera and consequently receive an image or stream from that camera. Its purpose is to determine if your camera is a good candidate for developing a supporting Control 4 driver. It also provides a fast, efficient way to create a still image camera driver for a project. The second part of the video will use Driver Editor and the Camera Driver Development template as a foundation to build a C4Z driver file supporting advanced camera functionality such as panning, camera tilt, and zooming. Before we move into assessing a camera for driver development, there are some items we need to consider. The first is obtaining the protocol information for the camera for which you wish to create a driver. It is important to obtain the latest protocol document from the camera's manufacturer. It will provide you with the device's communication syntax and notifications it will send to Control4's camera proxy. Something else to consider is the type of image streams your camera supplies and whether or not they are compatible with Control4 devices. This is important as certain streams are not supported on every device running Control4's Navigator. This includes touchscreens prior to the T3 version, which only support JPEG and Motion JPEG streams. T3 touchscreens support JPEG, Motion JPEG, and H.264 streams. On-screen Navigator, provided by HC and EA class controllers, support JPEG, Motion JPEG, and H.264 as well. So do the Control4 mobile apps. Finally, you'll need a list of approved URLs that you can use to test your camera driver. URLs supplied by the manufacturer are preferable. URLs will be needed for all of the imaging formats that you would like to support through your camera driver. By default, the camera template supports testing URLs for JPEG, Motion JPEG, and H.264. With this information in hand, we can get started with Part 1 of validating the compatibility of a camera using Control4's compatibility driver. As mentioned earlier, the first part of this video will demonstrate Control4's camera compatibility driver. You'll find this driver useful as it provides a quick way to verify the compatibility between the Control4 operating system and the camera you're considering for driver development. First, we'll open Composer Pro and search for the driver. Next, we'll double-click on the driver to add it to our project. The driver loads as IP Camera Test. Under the property areas of the driver, you'll need to enter the camera's IP address and change the port values if they are not the default of 80 and 554. You'll also need to enter the username and password information under the authentication area if they are required by your camera. Next, in the Advanced Properties area, you need to enter the manufacturer's URLs for the three stream types: Still JPEG, Motion JPEG, and H.264. When entering the string, you should enter only part of the URL, specifically the section after the IP address and port. So for example, if the manufacturer's URL for the JPEG image looks like this, you should only enter CGI/still_image.jpg into the property field for still JPEG URL. After you have entered the URLs, switch to the Camera Test tab to start testing the settings. For each of the display types, press its associated Get URL button. Now, review each of the URLs in the box to ensure that they are correct. If the URL is long, it may be easier to copy it from Composer Pro into a text editor for validation. Now, press the Test button. Composer Pro will now test to see if it can access the element on the URL provided. You should see the test image provided by the camera for the stream type you are testing. If you do not see an image or stream, it could be due to several reasons. If you see an error message that refers to GStreamer missing an element, then you'll need to update to the latest version of Composer Pro. If you encounter other errors, go back and make sure your URLs are correct. If there are alternative URLs for the camera, try those as well. If you are sure you have found the correct URL, but the image or stream does not display on the UIs, then you should assume that the camera's output is not compatible with Control4. Note that Control4 technical support is unable to provide any additional diagnosis in these instances. You are welcome to post any findings on the Control4 dealer forums in case other dealers have had success with this camera model. It's worth considering what we've just accomplished using the compatibility driver. By entering the correct URLs and receiving a stream from the camera, we have in essence created a functioning camera driver in our project. There are some limitations to this simple driver that are worth noting. They include no ability to pan, tilt, or zoom the camera. However, if your needs require a static camera driver, your driver is done. This driver could act as a temporary solution for supporting a camera at a job site. The customer would have still image camera support while you work on developing a fully functional driver to deliver at a later date. Just keep in mind that this driver cannot be exported to other projects using the URLs that you manually entered. Those URLs will need to be re-entered every time you add the driver to a different project. Now that we've verified if the camera we're working with is compatible with Control4, let's go into Driver Editor and take a look at the new camera template and review the steps necessary to create an IP camera driver. From within the Driver Editor toolbar, we'll select File and hold our mouse over the New menu option. Here, we are presented with several choices. In this demonstration, we're going to create a new driver project, or C4Z file, based on an existing template. So we'll select the Driver Project from Template option. When we do so, we can see the camera proxy template. Selecting it loads the template into the Driver Editor environment. At this point, it's worth explaining a Driver Editor construct that is important to understand. Driver Editor 3.0 views C4Z files as a project. When a C4Z file is loaded into its environment, Driver Editor organizes the C4Z into a structured project and displays it in the Driver Project window. Due to the organized structure of a C4Z file, it's easier to consider our driver as a project while working within the Driver Editor 3.0 environment. This is also a good time to discuss where Control4 driver templates reside on your system. Driver templates are delivered by Control4 through the Driver Editor development environment and will always reside in the following directory. See Program Files, Control4, Driver Editor 3.0, Templates. You will also find a driver template directory in this location. See User's Username, Documents, Control4, Driver Templates. This directory is created for you to store driver templates that you have customized or created on your own. It is important to keep these templates separate from the Control4 supplied templates, as the Driver Editor Templates directory is overwritten upon an update of Driver Editor. Along with the templates overview documentation, you'll also notice the driver project area of the screen. Here is where we can see the project framework that is provided through the camera template. At first glance, it may seem like there are lots of files and directories. However, it's actually numerous Lua files organized by purpose. You'll notice that some of them are in libraries as well. Here is our driver's XML file, and also driver documentation in a rich text file. If you are familiar with the C4I file structure, you'll remember that all of this would have previously resided at one level within the confines of a single C4I file. If you want to open one of the Lua files in the project, simply click on it and its contents are displayed in Driver Editor's editing window. For example, let's open the project's main driver.lua file. This file is significant as it contains all of the required statements for our driver, as well as the initialization code that is executed when our driver loads. We can also see our driver's XML content in the window by opening the driver.xml file. When we double-click the file, we can see the high-level XML in the driver configuration window. Many of our driver's XML information is edited by double-clicking on any of the top-level elements. This displays Driver Editor's XML editing screen. Here, numerous XML entries can be modified and easily saved in our driver project. The more complex XML elements can also be opened and edited in the driver configuration screen. For example, if we open the proxy's XML entry, we can see a high-level view of its contents. Double-clicking on the proxy value will display the proxy editing screen where changes can be made and saved into our project. You will find that the UI in Driver Editor presents XML based on the data types and amount of data that a particular element contains. For example, if we go into Capabilities and double-click on the Modes element, the Driver Editor screen will display a window to add, delete, or edit auxiliary features that our camera supports. Let's go back into Driver Project and look at one more thing. I can toggle between Driver Configuration and Driver Project by using the tabs at the bottom of the Driver Editor screen. Here is the documentation RTF file. Double-clicking on the file opens an editing screen which supports rich text formatting. Font assignment, images, and hyperlinks are all supported in this area. This provides you with an excellent opportunity to deliver quality driver documentation to integrators who are using your drivers in commercial or residential systems. Now, let's begin to modify this template and turn it into a publishable C4Z file which supports our IP camera. In this section of the video, we'll show you examples of each of the development steps to complete the driver. These include adding URL strings to the template, handling proxy notifications from the camera to the Control4 UI, handling proxy commands from the Control4 UI to the camera, updating the XML for the driver, adding documentation to support our driver, building the driver in Driver Editor, validating the driver in Driver Editor, and finally, publishing the finished C4Z file. When we open the proxy commands.lua file tab, we're presented with the Lua portion of the camera template. In the introduction to this video, we indicated the need to use valid URLs. Here is where they come into play when creating our driver. We will use the URL for obtaining a JPEG from the camera by storing it in a local variable named snapshot query string, which can be found in the UI req get snapshot query string function. We will replace the sample text between the quotes with our valid URL. In this particular example, this variable declaration can be found on line 174. If you are using a different template, simply do a string search on the function name to locate this line of code. It's important to take a moment and discuss the components of a URL and which pieces we need to include and which ones we need to remove. Here is what our original URL looks like. In order for the template to use the URL, we need to remove the following pieces: the HTTP, the IP address or host name, and the port number. Now we have a string that looks like this. We need to take this string and place it into line 174 so it looks like this. Now let's take a look at line 185. This is the line of code that we need to modify to include the URL for our motion JPEG signal from our camera. Again, we'll need to strip off the unnecessary pieces of the URL and add it as follows. If we scroll down to line 196, we'll find our template entry for the H264 URL. We'll modify the code just like we did in the two previous examples. Now that the template has the correct URLs, let's look at how to modify the template to handle communication between the camera and the Control4 system. To start, let's look at handling data flow coming from our camera to the Control4 user interface. We will call these data messages notifications. If you are familiar with other driver development templates, you're going to notice that the camera template handles notifications differently. Part of this is due to the fact that cameras have very few notifications. If we open the proxy and protocol guide, we can see that the camera proxy supports only 3. The good news is, modifying the template to support notifications is rather easy. We'll use the property defaults notification as an example. Let's take a closer look at this in the driver editor environment. If we open the camera proxy notifies.lua file, we can see the template already has a notification function for property defaults already created for us. If we look at the documentation again, we can see that this notification is sent through the onDriverLateInit command. Let's look at that command in the proxy init.lua file. At the bottom of the file, we can see onDriverLateInit, as mentioned in the documentation, where it calls property defaults. More importantly, let's look at onDriverInit, which is just above. Here we can see all of the parameters for the property defaults are initialized. Notice that they all come from the template API getCapability. This means that we need to go into the capabilities area of the template and define these parameters so the notification has the correct data to populate the Control4 camera UI. Let's open Driver Project and look at the Capabilities XML. If we open the Capabilities XML tree, we can see all of the camera capabilities included in the template. Note that they are all populated with default values for you. Also note that this group of capabilities are the same as the parameters for the property defaults notification. To support the notification, your job as a driver writer is to populate these capabilities with the correct values. To do so, simply double-click on the capability and use the Capabilities Edit screen to update the default values. You should also, at this time, review the remaining capabilities and their default values. Now is a good time to go through them and make sure they accurately reflect the functionality of the camera for which you are creating a driver. New capabilities are added by clicking on the plus button at the bottom of the Capabilities Edit screen. Now, let's change directions and take a look at communication flow coming from the Control4 UI to our camera. When we refer to the Control4 UI, we're talking about the initiation of a camera message being sent to the camera from user interaction through any device running Navigator or Composer Pro's control. We call these messages proxy commands. When a message is initiated, it first calls Control4's camera proxy. The proxy then calls into the Control4 API received from proxy, which in turn calls into the camera proxy commands.lua file using the PRX_CMD command table structure. Camera proxy commands.lua is a template file that receives the command from the camera proxy and handles it for you, the driver developer, by modifying its format as well as its parameters. For example, calls the camera proxy commands.lua file, then calls into the camera proxy class.lua file. This is a template file that stores device-specific data within the driver template. It receives the modified command and it extracts its tparams table into one or many individual parameter elements for you. In doing so, it also modifies the format of the command further. For example, calls the modified version of the command is then delivered to the proxy commands.lua file. Here is where you, the driver developer, needs to receive the command and its parameters, modify them in a manner that is valid for the camera, and subsequently send the command to the camera via the designated communication method. Now, let's take a look at an example of the functions that are included in the proxy commands.lua file. In doing so, you will also see how the camera template uses Lua tables to store most of the data required to build functional commands. By using tables in this manner, we were able to keep the actual function code in small, easy-to-read code blocks. Here, we see the pan left function as it is delivered in the template. You will notice the to-do line indicates that you need to provide the values used by the camera for panning left. A value needs to be placed within the quotes for local command line, which represents the camera's protocol command for panning the camera in the left direction. By referencing our camera's protocol documentation, we know that the following string is assigned for panning left. This string is entered between the quotes for the local query string. Our code for the pan left command now looks like this. You will need to enter the correct protocol strings for any functionality that your camera supports, such as pan right, tilt up, tilt down, zoom in, and zoom out. Now, let's look at the XML portion of our driver. As we stated earlier, there is only one XML file in our project, driver.xml. Notice that the driver.xml file name cannot be changed in the template, as Driver Editor expects a driver.xml to be presented when it builds our C4Z file. That file is edited through the Driver Project screen on the right-hand side of Driver Editor. The camera for which we'll be creating a driver in this video is the Acme IP camera, so we'll change the manufacturer and model field to reflect that. Next, we'll name our driver. This entry is important as it will be displayed in places where users will be looking for our driver. A driver name should be descriptive and informative. We'll name this driver Acme IP driver. We'll leave the creator value unchanged for our purposes, but this entry could be a developer name or a company name. Next is the version field. Since this is our first iteration of this driver, we'll leave the version at 1. However, you can start your versioning as you see fit, as long as the version numbers used are integers. We can also update the created entry. This is useful as it provides a date stamp when our driver development was initiated. You can modify the time and date elements by highlighting each and using the arrow buttons. You can also set the field to the current date and time by clicking on the plus icon. The modified field functions similarly to the created entry and offers you a way to assign a time and date stamp to further driver modifications. We'll set our modified date as the same as our created entry. You can also set the modified date element on a system-wide level under the Tools Options menu. Select Dates and you are presented with 3 choices for how the modified date field will be populated. Manually, as we have just demonstrated. Upon saving a driver, the modified field will be updated, or you can choose to have the field updated upon publishing the driver. Those are all the changes we need to make to the main XML page for our driver. All of the remaining values are set correctly by default for us from the camera proxy template. At this point, we've configured all of the high-level XML information for our driver. Now we'll quickly look at the proxies. We verify that the camera proxy is already added for us, so there is nothing more to do here. We've already reviewed the camera template capabilities when we updated them to support notifications, so there should be nothing to do here at this point. Next, we'll take a look at the Connections tab. You will notice that the camera driver template has one pre-populated connection. Also, if we open up the Classes section, we can see that the correct class name is already provided. The camera template supplies all of the necessary connection information for our driver by default. Finally, we'll include some documentation with our driver which will help integrators with setting up and configuring the camera. To do that, we'll open up the documentation.rtf file and either copy pre-existing content into it or create it right inside the window. This content will be displayed in Composer Pro under the Properties Documentation area for our driver. At this point, we've reviewed and modified all of the key components of our driver project. Driver Editor provides several tools for us to finalize the project and eventually publish it as a working C4Z file. The first step in this process is building the C4Z project file that we've been modifying. The build process does several things. First, it saves all of the files in the project. Then it creates a C4Z file from the list of files found inside the Driver Editor under our C4Z proj file. To build our project, we'll open the Projects tab from the toolbar and select the Build option. Alternately, you can use the shortcut key of F6. When the build of the project is complete, the output window is updated with the results. The next step in our process is to validate our newly created C4Z file. It is important to understand that a project must be built before it is validated. If you select Validate before building, Driver Editor will force a build of the C4Z proj file to create a C4Z and then perform the validation. The validation step is useful as it leverages a set of generic tests supplied by Control4 and delivered within Driver Editor, which reviews the driver XML for correct XML structure and valid content. It also compiles all of the .lua files and validates them for correct syntax. To validate our C4Z file, once again open the Project tab from the toolbar and select Validate. F7 will also initiate the validation process. Before validation begins, you can set the verbosity level of the validation process, as well as the level at which logging will be displayed in the output window once validation has completed. Verbosity level gives a listing of the tests that were performed against our driver, as well as the status of pass or fail. Let's select the Most option here, as this setting will provide us with additional information in the event that a test fails. We'll select Debug Logging Level, as we'd like to see any log content that will help us figure out where an issue may be within our driver. Clicking the Validate button begins the process. Here we can see the log file contents of our C4Z validation. The log shows us all of the tests which were run against our XML and Lua code, as well as the results. Using Driver Editor, we have built a C4Z driver from our C4Z proj file. Next, we validated the C4Z for invalid content. Now, we are ready to publish our finished IP camera driver. The Publish function in Driver Editor is useful as it places the finished C4Z file in a designated area which can be devoted to completed drivers. You can designate this directory by clicking on Tools from the Driver Editor toolbar. Select Options, followed by Workspace. Here, you can designate a target directory for your driver project directory. This is where all of your driver projects are kept before they become C4Z files. The Build directory allows you to designate a place where your drivers can be built and saved iteratively as you make changes to the driver's code. Finally, the Publish directory is where your completed publishable drivers will reside. Having a different Publish and Build directory allows you to make changes to a driver that is maintained in the Build directory while still providing a published version of that same driver. This concludes the template-based IP camera driver development video. We hope that you found the information presented here informative and helpful in assisting you with developing Control4 drivers for IP cameras.